Hello, everyone, and welcome to this week's Kafka live stream. I'm your host, Adam Noonan. We'll give it a couple minutes, let everyone join and roll in. As always, as we're talking, if you have any questions, feel free to chime in on the chat. And if you're watching this on YouTube, definitely tune in live next time on Zoom. Actively participate. Today, I'll be joined by my good friend Ivan. Ivan, have we pulled you up to the panelists yet?
Hello.
Hey, there he is. How's it going?
Not bad. We are approaching the days that are just gonna be sunny, so you got to feel good, yeah.
Definitely in the air.
Well, in Madrid, yeah, those days came way back.
I'm excited. The pollen's starting to die down a little bit. It's getting even hotter. My allergies are coming down. It's cool season. Awesome. Well, thanks again, everybody, for joining. This is our week's Kafka live stream, where we share some tips and tricks on working with Apache Kafka, trends we're seeing in the market. As I mentioned, I'm joined by my good friend Ivan today, and we'll be talking about under-replicated partitions and working with Apache Kafka. So let's talk under-replicated partitions, or URPs. To start us off with some base knowledge and definitions of some concepts we'll be talking through today. We've got some definitions here. We'll be defining the concepts of topic, partitions, partition replicas, and then in-sync and out-of-sync replicas. And I've got a good visual description here, if everyone can see my Excalidraw. So when we're talking about Kafka, we'll usually start with the producer side. So we've got an application or connector. It's going to be writing to Kafka. So here we've got a Python application running in a Docker typically, and it's going to be producing data to our topic. So essentially will be messages. So we're sending a stream of messages into a topic. Should all be pretty familiar if we're worked with Kafka before. And the way to think about a topic is essentially the analogy commonly used as a table. This is going to be a singular store for our data. It's also referred to as an event log, since we're sending streams of messages in sequential order. So this would be our producer sending messages with keys and values to our topic. And as we talked about last week, that key value is going to determine what partition we're writing to. So each topic is composed of partitions. So we've got the full topic as a whole. The application knows it's writing to this topic, and then Kafka will determine which partition to add a message to. Like we talked about last week, you can ensure that the ordering is exact for each specific partition, but not across the entire topic. So we've got our producer. It's going to send a message to Kafka at a topic location. Kafka is going to determine which partition to write this message to within that topic. And Kafka does this so that we can parallelize the load. So to maximize throughput and for scalability, we're going to write different messages to different partitions. That's going to allow us to write faster and then consume those messages faster too, so we can sort of scale horizontally. So each topic consists of multiple partitions, and we'll look at partition 0. We've got our Python application writing to the end of this topic. It's going to be appended here. But then within each partition also consists of different types. In order for data availability and security, we're going to have replicas of this partition. So in this example, we have 4 different partitions, but each of these 4 partitions are going to have copies of that exact same data. And those copies are going to be spread across the entire Kafka cluster. So we've got partition 0 here, and then this partition has 7 different replicas. And those replicas are going to be on different brokers within the Kafka cluster. Each partition has one replica leader, partition leader, and that is going to be the partition that applications are writing to and consuming from. So it's going to take the workload of reading and writing data on that leader partition. And then the way that data gets shared and replicated across the replicas is going to effectively disseminate all those new messages rolling into that leader partition across the entire cluster. So that if that broker goes down that has that leader partition, a different partition can step up and start serving that data and handling that workload. So we can see we've got our leader partition that's getting written to. We also have a consuming application reading from that partition. And then we have sort of that data being replicated out across the cluster. Again, that exact same data. Since we have let's say the most recent message was message 9, then we would say that these partitions are in sync. They're up to date. They have the exact same data that the leader partition does. And then these replicas, which are still catching up, we would call under-replicated. Does that sound right? Yvonne, anything I messed up you'd like to correct?
No, you did it. It makes completely sense.
Perfect. Awesome. With the 101 out of the way, I'll hand it off to you, sir.
Yeah, since we covered the most important definitions before we go to the topic of under-replicated partitions, there's one more thing, and that's partition replication. So to start, if you have multiple replicas, of course you need to enable and you need to increase the replication factor. And why that is important? That's basically a critical part of the Kafka system, because it offers you availability and it offers you also durability. You mentioned there are about the replicas and how you have replicas, and basically when we mentioned the replicas, you also mentioned the leaders and some which are catching up. That's basically how we can categorize the replicas. There are two types of replicas. There is a leader replica. Basically, every single partition that you have in a topic has a single replica that is designated as a leader. And the main goal of that leader replica is to handle all of these produce requests that are coming into that you described. And with it, you are basically ensuring and guaranteeing the consistency. While the producers can produce only to the leader partition or leader replica, that's not the case, for example, for the consumers. Consumers can consume from one replica, from the leader replica, and also from the follower, which we are gonna come to in a second. So from the follower and also from the leader. Now, this feature was not enabled and wasn't here until recently when the CAPE 392 came across, and which introduced actually consuming from the follower replicas. Now, why is that? Why that came across people's developers' mind, and why this one was introduced? Essentially, the main goal of this one is to decrease a network traffic costs. If you're in cloud or you have, let's say, multiple AZs of your Kafka cluster, and you have only one or two AZs from which your clients are consuming, you essentially want to reduce the cost and you want to reduce the traffic and in the end the latency. So this was the perfect thing to do. Now, while this can come with the good stuff, as I said, reducing all sorts of stuff, it also has many cons. Now, we are not going to go into the cons right now, as it is a big topic. So I would encourage you all, if you really want to talk about this topic, this KEEP or any other topic, just comment down below any other ideas for this one or for something else, and we'll try to do it in a later webinars. But as we said, the goal of the leader replica is to handle all produce requests, and it's also the goal is to know which replicas are actually up to date. Now, as we mentioned, the leader replica, we also have follower replica, and essentially whatever is not leader replica, it's actually a follower replica. And these are the ones which are trying to catch up with the leaders. They are the ones, if of course it's not configured otherwise. The whole main goal of follower replicas is to replicate the messages which came to the leader partitions, leader replica, and basically stay up to date. Yeah. And now that being said, now that we have everything that we wanted to actually mention and discuss and to elaborate, it's actually a good moment to start with actually mentioning what under-replicated partitions are. So under-replicated partition is a term. In essence, that's that's actually an effect. It's an action that happens. Whether it happens naturally or it is invoked or it's not invoked, it came suddenly. In essence, it tells you that something is wrong with your replicas. As the same sentence says, basically, if the leader plus the number of in-sync replicas is below the number of all replicas in the cluster, that means you have under-replicated partitions. Now you have to figure it out which brokers or actually whole cluster is lagging behind, which partitions are those, and from those you can actually figure out which brokers are maybe lagging. Now, yes, we can categorize it, group it, and say this is usually caused by a single broker problems. It can be, as I said, a hardware software. We're going to go into that, drill down into it later on. It can be overloaded cluster and overall cluster that is having big issues, or it's actually controller problems. You have some sort of bug that you are dealing with. But yeah, to go more into of how this can happen. How this can happen and drill down more into the details. We're gonna jump a couple of slides in front. So how URPs can happen is following. It can happen because you have some sort of network glitch or network congestion. Network is a huge area where actually even partial failures will cause a lot of problems. You can have some of these problems are actually hardware issues. You have some bad network cable or a bad connector that has to be replaced, or there are some configuration issues, which is usually a change in speed or duplex settings for the configuration, either on the server side or the upstream on the network hardware. Also, network configurations. The network configuration problems could also be tied up to the OS itself, because let's say you are having a network buffers which are undersized, or you have too many network connections. They're taking just too much of the overall memory footprint. So if the key indicators of problems in this area, usually you will find a huge number of errors in the metrics somewhere in the panels, graphs, under the network interfaces. Usually these ones can be found in the peak hours or peak days. If your company has it, you work for some big company where you know that certain peak of orders or something will happen in 9 a.m. or 10 a.m. or something like that, and you haven't scaled your cluster, or you didn't have capacity planning properly. It can happen as another category, which is a broker failure, which doesn't necessarily mean just hardware failures. Yeah, we meet with hardware failures constantly. It can be your disk just went south or anything as such, but it can happen because your VM or your bare metal was brought down by some tool for patching. You might have security violations that had to be patched, or operating system that has to be upgraded. So just quickly bringing down the machine, make a patching, and then bringing it back. It's not necessarily a bad thing. Your cluster still can live on. It can happen with a high load, whether CPU, memory usage, big memory usage. You have high disk I/O, which your broker couldn't withstand, or your basically underlying software couldn't withstand, or hardware. And in the very end, reassigning of partitions or rebalancing. Now, this is a huge one because you might actually have some sort of rebalancing job, which is running daily or weekly, and you want to rebalance your cluster by, I don't know, It can be disk utilization, it can be leaders per number of leaders per broker that you want to balance it by CPU, by network, ingress or egress, so many various goals that you want to rebalancing. Every time you rebalance or you run reassigning partition tool, you will see a small spike of under-replicated partitions. Whether that's good, whether that's bad, it's not bad. So, but those types of scenarios can cause reassigning of partitions. So is it actually a bad thing to have URPs? Basically, having URPs doesn't always need to be bad, as I said. Therefore, it is really not recommended to really alert upon under-replicated partitions. Under-replicated partition metric is just here to tell you, hey, I am here because something has been wrong with your infrastructure for some time. So that's just a product of something. Under-replicated partitions can be there for 10 minutes, 15 minutes, but again, it can be a rebalancing thing and you can just ignore it. And it's very important that you don't create that alert fatigue because eventually you're just going to forget it. It's going to be there and you're just going to forget it. Well, it can actually be a huge operational issue. So, but how to fix it if you have it, whether you should fix it or not. First of all, you have to evaluate. We're not going to today talk about this is the perfect formula how you should be how you should fix your under-replicated partitions. There is no silver bullet for it. There's just no. There's so many various scenarios that you can't know how to approach it. As I said, it can be a broker down. You have to somehow also need to have metrics where you can check all these sorts of stuff. So I said it we wrote it 3 times because it is uber important. And it's not just metrics. Metrics is just one side of the story. You need to have logs as well. I've seen one too many times where people would just look at either the logs or just the metrics and try to make decision or debug it. You're not going to be able to debug it. For some situations, maybe, yeah. But for majority of those, you won't know where you are. There's just so many variables what actually went wrong. So first and foremost, yeah, you have to go down and see whether your broker is down. And whether your broker is down because of hardware issue or it can be out of memory issue, and then see what you can do with it. Don't try to just bring it back immediately. Bring it back while your disk is full is just going to bring it down again. You're not going to do anything. Or if you had out of memory issue, it's going to happen again. So try to evaluate what really happened with it and do something with it. Do some configuration issue or a configuration change, or if it's a problem with your disk, try to evaluate which topics you can reduce retention or whether you can increase disk size by at least by a little to bring up your broker and then reduce the retention. The perfect thing to check or metric to check is replication lag. Usually, if replication lag started to build up, you would see under-replicated partitions. And if you see replication lag building up, that means most likely your disk I/O wasn't able to withstand the peak hours or something that caused so much traffic to go into. It might be your configuration in Kafka for replication throttle that is just peaked out, or it can be just you came across the peak of your current network boundaries you have. So you have to see what's actually causing it, because it might be actually perfect with your Kafka infrastructure. It might be some general bigger issue that you can't fix it yourself. You have to contact someone. If that's all good, maybe you are running a rebalance job. Also, be sure that even if you're running rebalance job, you're going to see replication lag. So it is very important to know whether anything is happening in your cluster when it comes to the rebalancing. Did someone write some heavy reassigning of partitions because she saw something in a cluster? You have to know what's actually happening. And then even if you're running it, try to see what's the replication throttle, whether it's adequately being set, because otherwise you're gonna have a bigger. Otherwise, it's just gonna peak out, and you're gonna have that issue. Then, and in the end, it can also be the good thing to check is also a request metrics. You have a produce and fetch request metrics. These are the key to help you monitor how request handling time. Basically, high latencies on these might indicate that actually something bad is happening with your broker. And that could actually be leading to the under-replicated partition. So these are actually very good to check. So once you evaluate what's actually happening with your broker or cluster in general, once you check it, then you might know what actually to do. What's your next step? Should you just leave it out because it was just a rebalancing job that you were running, or it was just a broker that went down for the security patching, or you actually had the flapping broker or flapping VM or bare metal, which has been fixed a couple of times on hardware level, but the issues are happening again and again. I would or maybe you are afraid to replace that VM because you know it's going to wipe all your data, and then you are afraid of how I'm going to replicate all of that data. Believe me, the easiest part to do is replicate the data. That's what Kafka does out of the box. I have been in situations where I have been replicated hundreds of gigabytes of data over dozens of terabytes of data. It goes quickly. You just have to, I mean, quickly, depends on your network, of course, but it's the least expensive thing to do if you check it in a long term of your infrastructure and how you will be handling the issues, because the issues will, if that one box is constantly having issues, you're just going to have too much an overhead on your cluster, and essentially your clients will be knocking at your door asking you what are you doing, because they're having constantly operational issues. And the second thing that you can work on is to have reassignment partition tool next to you. Usually under-replicated partitions are coming because one broker is overloaded. People are not rebalancing their clusters. They're not thinking about how partitions are balanced, and it can very much happen that one broker has one too many partitions that it is leader of, and these partitions are really pressured with the ingress. Try to measure try to see the ingress as well, and try to reassign those partitions to other brokers. That's your main goal as a Kafka admin. You have to constantly watch for the balancedness of the cluster, and that's where the tool as a cruise control is perfect at. You should be utilizing those tools so you can work it through. You can see how your cluster is behaving and balance your cluster in the most efficient way constantly every week, if so. And also preferred replica election. There's a tool to enable it automatically, but I would not really advise it to use it because it can happen in the situations where there is a peak traffic happening, and then you are not reshuffling, but making a preferred replica election, changing the election. So to keep it manually and do it only when certain actions happen on the rebalance or things as such.
Just pause there real quick, and I think a summary, because that was a lot of really great info. So if I'm understanding right, under-replicated partitions, not always a big problem. Sometimes it's just a natural state of things, especially when it comes to rebalancing. So when you are experiencing under-replicated partitions, don't freak out. Check the metrics to see if there's actually an issue here.
Absolutely.
And we're mentioning rebalancing a lot. I didn't define that at the beginning. Maybe if you could define that now for us, Ivan, so people...
Rebalancing. Yeah, definitely. So rebalance is the job that you where you shuffle and pick which brokers are going to be leaders of which partitions. As we said, the leaders of partitions, leader replica, are the ones which are main goal is to where the producer traffic is routed to. That's their main goal, to accept the traffic. So it can happen throughout your life cycle of infrastructure that you're just shoveling too many leadership partition to one broker. You don't want to do that. So with the rebalance or reassigning partitions, you can shuffle or use the excess of the partitions that the one broker is leader of and push it to some others, give more leadership to those. And there you are actually balancing the load which is coming to your cluster. You can have, by the message bytes coming in, you can actually see the discrepancy by the brokers, how much traffic they are receiving. That could actually give you a glance of, naturally, it doesn't, there's many goals. You can utilize it by network ingress, egress, you can utilize it by CPU, so many stuff. But you should be able to looking at those because ultimately that's something that can cause you the under-replicated partitions.
Makes sense. Perfect. So in order to make sure the load is balanced as far as producers and writes to Kafka, you shift around the leader partitions so it's equally distributed amongst
Yeah.
them.
Yeah.
Awesome. What shouldn't we do?
So what shouldn't we do? You shouldn't, as soon as under-replicated partitions happen, I've seen it too many times. People try to immediately roll restart the cluster. And that's, as much as some people advise it to do on the internet, I wouldn't really advise it because you're not gonna, there's nothing good that can come out of it. You're just hiding, like in your life. If you try to, if there is a problem in front of you and you put it under the carpet, or you don't want to discuss about it, it's gonna reappear sooner or later. It's gonna bite you. So don't do the rolling restart to try to fix something quickly. In majority of the cases, you won't even be able to fix it. Try to evaluate what's happening. And with evaluation of what's happening, you will be able to recognize the issue and fix it so it doesn't happen again. That the other thing that I've seen people are doing, as soon as there's unreplicated partitions, they can't figure out either they don't have the good amount of metrics to look, or they don't know what to do. They go ahead and they enable the unclean leader election, which is very bad. That's the least you want to do. It's if all else fails and you have been struggling for weeks and no one can help you and you cannot help yourself, because that basically majority of the cases mean potential data loss. Because what you're gonna do, you're just gonna give the leadership to the replicas that might not be in sync. That's why it is called unclean leader election. And basically you lost your data there. You're gonna be fine for an hour or two, and then there are going to be people knocking at your door. I lost my data. Where is my data? I lost half an hour of my data. So you're going to be in big mess. As I said, metrics might tell you one side of the story. Don't ignore the logs. People are ignoring the logs, or other way around. I'm not sure why, but check the both. Read the logs and then check at the exact time what really happened in what metrics are telling you. Don't use replication factor of 1. You're not going to achieve anything. And do not alert as soon as URPs happen. It's a bad thing. You're just going to have alert fatigue, and you're never going to check these alerts again. You're just going to say, it's again. It's going to fix it itself. Don't do that. At the very end, you might have the metrics to look after. When you have URPs, from the replication lag to the as we said, max lag. It can very much help you. It can help you the ingress, as we mentioned. Check the ingress, how per broker level, how much is distinguished each broker, how much data it is getting, whether the log flush stats, basically that metric is useful to understanding how frequently and how long it takes brokers to flush the logs. Request handler idle ratio basically indicates the proportion of the request handler threads and how much they're idle. Basically, how much it takes for all the requests to be processed in terms of how busy your brokers are. These are just some of them. There's so many others. We all know that Kafka has hundreds of, and not hundreds of thousands of metrics. Just try to go over all of these. Don't try to go all of these. Try to pick some of them. Also system and network metrics, and if you need more, then go through more. But at least pick some of them when debugging, and then just grow over it and ask for more. Look for more if you really need it.
Check the metrics, check the metrics, check the metrics.
Yeah.
We have one question in chat I'd like to get to before we wrap. That's all right.
Sure. So it says, would a consumer that consumes from a partition that became unsynced generate a rebalance for that consumer? So generally, the consumers, even if the one broker is down, it would just continue read. There would be a small fetch. You would see inside the request something like no leader for a partition, a small issue. It would cause us like small rebalance, and it would just continue work as is. So you would, in your logs for the fetch request, you would just see a small no leader for partition issues, and it would just continue work as is. Basically, even if you lose two partitions, it will be able to, but this time in read-only, you won't be able to produce. It will be able to continue in read-only, but the consumer would not be aware of what exactly the issue, the under-replicated partitions. I mean, it wouldn't. It would get from the brokers the error, well, a small warning or error message saying, yeah, there's no leader of partition, and it would just reshuffle and continue from the new leaders when the election would happen.
Perfect. Great question. Great answer. Thank you so much, Ivan, and everyone who participated. Really appreciate your attendance and your attention. As always, if you have any questions for us and the wider team at Lenses, feel free to join our Slack community. You can contact us all directly there, get product updates, and be informed for any workshops, webinars, and live streams in the future. And that will be it for today. Thank you all so much for attending this week's Kafka live stream. Definitely tune in for the same time next week for a quick 30 minutes on tips and tricks working with Apache Kafka. Thanks again, Ivan. Much appreciated.
Thank you all.
Y'all. Thank you so much.